So we continue from the last video. We're talking about actor objects and the actor class. And we finished off the last video by talking about these instance variables, which store the state of an actor object. And almost all classes are going to have instance variables, and the number will vary. You could have a whole bunch. It all depends on what information you need to store about the state of the object. So, so let's just look at this a little bit more. And this relates to pages 52 and 53 in your book, which also go over the actor class. So this just should reinforce that. So we've got comments here at the top. Comments are important. You should get in the habit of putting some comments in as you get to writing classes that explain that you're the author of the class and what it was an assignment for. We have our import statements that make some other classes easily accessible for this class. Some more comments. So every class basically starts out like this: public class actor. Some classes extend other classes, like the bug class, but actor doesn't. So although I should say every Java class extends the object class, which is sort of the Adam and Eve of objects for Java. So it's a little tricky. We won't get into that now, but by default, every object extends every class you create extends the object class, but you don't need to write that there. Nobody does. It's not needed. It's just the way it is. Okay, so here are the instance variables. We went over these last time. We won't do it again. They store the state of a particular object of this class. This is new. This is known as a constructor. Almost every class you write will have one or more constructors, and the constructors are used quite simply for setting the starting values of the instance variables. Almost always, that's all they do, right? So in this case, we're setting the actor to blue. We're setting its direction to north, and setting the grid to null and location to null. We'll ignore those things for now, but that's the starting condition of every actor when it's created. Okay? Now, just go back here for a second. All instance variables are almost always defined as private. And the reason for that is we only want the object itself to be able to change them. We don't want other classes coming in here and changing these without the object knowing about it, basically. So, and that reason for that relates to APIs and the advantages of APIs in controlling access to the internals of things. So the internals of things. Well, basically, what you want to be able to isolate your instance variables from being changed accidentally by other classes. We'll just leave it at that for now. Okay. So they're always defined as private, but we clearly can change them, right? I mean, if we go here, we can change the colors of these to different colors. So how's that happening? Purple. Wow. So most classes will have what are known as accessor and mutator methods. They're specifically designed to change the values of the instance variables. So we've got this illustrated perfectly here. This is an accessor method, get color. It returns, this word is what sort of that thing a method returns. And this method returns a color object. And what we're returning here is what is the color object that's stored in this particular object of the actor class's color field. Okay? And we want to be able to set the color, which is what we just did back on the grid. And this is a mutator method, or sometimes called a setter method. Thus the use of the word set. By the way, this is sometimes called a getter method, thus the use of the word get. So the mutator method. this changes a field, but it basically what it does is it asks the actor method by calling its setColor method. It says, hey, actor object, would you please change your color to a new color which I'm supplying to you, right? This way, the actor object, in essence, is the one that makes the change, and it knows about the change, so the change doesn't happen like without this particular actor object knowing that a request to change its color has occurred. And that's really important for avoiding all kinds of bugs in computer programs. So accessor methods and mutator methods. And generally you will have an accessor and a mutator method for many of your fields, not necessarily all of them, but for ones that it may be important to change due to the needs of the larger program, you will have accessor and mutator methods for those. Okay? So we've got then, in these three methods, we've got some of the key method types that we use throughout the year. We've got a constructor, and we'll spend more time on constructors because each class can have more than one constructor, and won't get to that right now. This is the accessor, the mutator, and again we have this is a mutator. Sorry, this is an accessor method for the direction. It returns an int, so direction in this case is a number between 0 and 365. And here's set direction. This is a mutator method. Now notice the use of the word void, which is common with mutator methods. These methods, you're passing in information, right? You're passing in a new direction. You're not getting anything back. The method is not returning anything. So we specified the return type is void. And if we go up to this other mutator accessor method, sorry, this other mutator method, I apologize, it is also void, right? We're passing in a new color. We're not getting out back what the existing color is. All right, and that's all I'm going to do in this video. That's quite a bit. I hope it's starting to be clear. You should definitely read the book again on page 52 and 53, which goes over all this information in text. Okay, so with that, I will close this class. Okay, thanks.